Hello, in this video we will talk about ANOVA as a regression, and we're using R for both analysis. So ANOVA and regression actually are both the case of the so-called general linear model, because it assumes the effect of the response variable from the independent variable and linearly by the parameters. And ANOVA actually is to estimate or analyze if different values from the treatment group have the same effect on the response variable. And the linear regression is to estimate when individual magnitude of the increase in independent variable and its effect on the response variable. It can be having multiple independent variables in one linear regression equation. In R, we use AOV function for the ANOVA and LM for the linear regression. And linear regression model actually is also alternative approach to ANOVA if you want to know the difference between different independent variables on the response variable. If those independent variables are different values from the treatment groups in ANOVA. So next we will show examples for both of them. So first we go to RStudio and we will use the data code crossflow from the package multi-comp. So we run this to get the data and we will show so this is the data set for crossflow. Actually it includes two columns. One is treatment TRT. You can see TRT values are 1 time, 2 times, 4 times, and the drug D and the drug E. So these 5 values belongs to the treatment group, different groups value. And response is the continuous variables. So we also show the levels using the levels function to get the different values of the treatment group. So 1 time, 2 times, 4 times, drug D and drug E. So next we will run the ANOVA function to test if different treatment group will have the same effect on response variable. So we just run AOV response, then tilde symbol. In R, we use tilde symbol. On the right side, the factor variable TRT and the data frame. We show the results of these ANOVA results. You can see the TRT here, significant is highly significant, is almost 0. So if the significance level is 0.05, it is highly significant, so which tells us that different values from the treatment group will have different effect on response variable. But ANOVA does not tell which part of or which group of the treatment are different from the other groups. Then we can use another approach called linear regression. So AM, same expression as ANOVA response. And the right side of the tilde symbol is TRT, a data crossflow. Then we also show the summary of this test, this analysis. So regression shows the function, the expression, and residues. Then in the coefficient, because the regression is to measure the coefficient, which means the when unit magnitude increase or change in the independent variables on the response variable. So here you can see there are treatment 2 times, 4 times, drug D and drug E, but no 1 times treatment. Because this is by default contrast. So in the linear regression, there are contrast options. So by default, it will choose the first value from this variable. So this is actually the value from the variable TRT, right? So choose the first value as the base variable. So the other 4 values will be transformed as variables. So if we take this called contrast close to TRT, so you can see this is called a dummy variable. So dummy variable is that there are several variables, but for one observation is only one value is 1, the other 4 values will be 0. And actually this is the contrast with the baseline. The baseline is baseline is 1 time, right? 1 time odd 4 dummy variables are 0. Then for the 2 times, only 1 is 1, other 3 is 0, and so on. 4 times is also here is 1, others 4, 3, 0. So in the contrast, by default, is to set the first value of TRT variable is baseline. The other 4 values will transform as dummy variables with only 1 for each observations. So we show these results again. Here in the regression, the baseline here is this interceptor, but baseline does not show, and 2 times, 4 times drug D and drug E estimated parameters compared with the baseline. So you can see, for example, here is 3.443. So for each unit change in the 2 times, it will have 3.443 more effect on the response variable than 1 times, right? And for the 4 times, there are about 6.6 units in the response variable more than 1 times for the 1 unit change in the independent variables. And all 4 parameters are significant. This is one stand, other 3 highly significant. So which means if we compare these 4 values treatment group with 1 times, they are all different. So which means which will maybe the reason for ANOVA such significant, because ANOVA will tell us that not all the same, but we do not know which 2 pairs not the same. So regression can show at least, but not all, at least these 4 groups are not the same as 1 times, right? And although there are more complicated contrast options in the linear regression. So if you are interested in, you can check the function and other examples. There are more complicated different types of contrast settings. For example, if you want to compare these 2 or compare these 2, but here does not show, only show the results comparing with the first value of treatment. So this is what we show in this video for the 2 approaches. For one is ANOVA and one is linear regression, showing the effect from the different values of the treatment group on the response variable. Thanks for watching.